Hi and welcome. In this video we're going to explore the Brep class in RhinoCommon. Let's go and head to the Rhino the geometry namespace and go to the Brep class. So in the Brep class, the Brep works again exactly like the surface and curve. It does not have constructors and you can only construct an empty Brep using the constructors. You can get the edges of the Brep, you can get its faces, you can get a lot of things. You can get the vertices of the Brep and the surfaces and so on. And a lot of methods are there for the Brep, actually 188. You can add an edge curve, you can add a surface to the Brep, you can append a copy of another Brep to this one. You can cap planar holes, you can find the closest point, you can do actually a lot of things, but the most important things is how to create a Brep. So in order to do that, search for the methods that start with the create word, and you can find here create Boolean difference, Boolean intersection, Boolean union, and a lot of things. And you can create loft. So search for create from. Here you can create from a box, you can create from a cone, you can create from corner points, or you can create from loft. So if you want to do the loft command in Rhino, you can use the brep.create from loft method, or you can create from sweep, and that will be sweep 1 and sweep 2. So let's try to create a Brep from loft. How can we do that? It returns a Brep array, and that's a static method, so we use the Brep class name, and it returns, as I said, a Brep array, and we use brep.create from loft, and all we have to add is a list of curves, a .3d start and .3d end, which are not necessary. We can just type .3d.unset and unset those points. We can choose to start if we want to start tangent and end tangent or not. We can choose if you want to start trim or end trim, or we can find an easier loft overload that doesn't take all of these parameters. It actually needs the list of curves, the .3d start and loft type, and to choose whether it's closed or not. Let's try on Rhino. Let's create two surfaces. So this is curve. Let's create two curves. This will be curve 1 and this will be curve 2. And let's change this a bit here, and let's connect these curves. So we'll set multiple curves here, and we'll make sure that these curves are connected to an input parameter that has a curve type and that has a list access, because we added two lists. So now we're going to create an array of Brep called Brep that equals to brep.create from loft. And here we need to add the curves, the .3d start, which will be .3d.unset. The .3d end will also be .3d.unset. The loft type will be normal, and we don't want it to be closed, so we write false, and a equals brep, and that's all. So if we run, here is our loft created, and it can be changed, of course. So this changes parametrically while changing this the points of this these curves. Okay, so how can we create a sweep? Actually, it's exactly the same as creating from loft, except we need a rail and a shape. So if we click here, and instead of creating the brep from loft, we'll create from sweep. And here we need a rail, a shape. We don't want it to be closed, and the tolerance will be 0.001, and we'll run this. And it won't run because we don't need curves here anymore. So we need only a rail that will have item access and a shape that will have a curve type. And now let's try and add the curves. So we need two curve components here, one here and one here. Let's say that this will be our rail, and we will have this as our shape. So let's move this here, and that's it. This will be our shape, and this will be our rail again, and here we go. All right, it went the other way. How can we redo this? This is because this curve maybe needs to be flipped. No, it's not the problem. Yes, we needed to flip this curve in order to have. So what if the curve is this way? Can we flip the curve? Let's check. I actually didn't do this in the curve tutorial, but let's try to flip our rail. So if we write rail dot flip, is there any flip or reverse? It worked or not? No, it did not work actually. Reverse doesn't do what we want. Let me check for a second. Okay, actually it works, but the point is we created the brep before flipping, or in this case in RhinoCommon it's called dot reverse method for a curve. We actually created the brep before reversing our rail. So if we just move the rail dot reverse method above the brep creation, it will work good. So flipping a curve is easy in RhinoCommon, and we can easily do that by typing the curve object's name and choosing dot reverse. Now what if we want to create sweep 2 geometry in Grasshopper in using RhinoCommon? All we have is to add a rail to this. Hopefully this will work without needing to add anything else. So let's create a rail to curve here, and let's copy this one here, and let's take a copy of this and set this curve to be the rail 2, which is probably okay. Flipping here is not the right. We need to flip the two curves actually. So rail dot reverse and rail 2 dot reverse, and this shall work good. Yes. So now if we change this rail, the shape changes with us, okay? Because now this very brep is a sweep of two rails. Okay, now let's check the properties and the methods of a brep. we can create from sweep as we did. We can, okay, there are a lot of overloads for the create from sweep, and especially because it contains the sweep 1 and sweep 2. We can create from tapered extrude. We can create offset brep, which offsets a brep. We can create a pipe. Okay, so if we have a rail and we want to make a pipe, we can use the create pipe method, which is really easy. It only takes the rail, the radius. Maybe there will be other easier, maybe there will be other easier overloads, or maybe I think there is a pipe. There should be a pipe class here, I think. No, there is no pipe class here. So okay, let's try to create a pipe on this curve, which is rail 1. So rail, we'll create a pipe which gives us brep, another brep actually, and is a static method. So we will create a brep array here called pipe that will be equal to brep dot create pipe, and here we'll add the our rail. We want a radius of say 1. Local blending false. I don't know what local blending is, but maybe I'll have to check it after finishing this video. If you want to cap the holes, so maybe yes, we want to cap the holes. The tolerance can be okay. There's fit rail. Let's make it true. Let's make this tolerance 0.001 and another tolerance 0.001, and let's try to see how this works. So b equals pipe, and if we run this, well, okay, we created our pipe here. And if we don't want to cap it, I think there's a non-parameter, right? So that we can hide these caps of the pipe. We can change now the radius. We can assign an input for the radius and parametrically update it, and we can do a lot of things. So here is how to make a pipe using the Brep class. Okay, now we can create planar Breps. We can create solid, adding the Brep list and a double tolerance. We can create thick pipe. We can call unused edges. We can call a lot of things here. We can duplicate the Brep. We can flip the entire Brep. We reverse the orientation of all faces of the Brep. We can get its area. Getting the area is actually means if the Brep is a box, it will get the area of the 6 sides of the box and so on. We can get the volume. We can check if it's a box, or we can join more than one Brep. And I think that's it. We can rotate, we can do all the transformations possible. We can split a Brep, we can translate it, we can trim it, and so on. So I hope this tutorial was helpful for you. I hope you enjoy the way I'm explaining things, and if you have any comments, kindly leave them in the comments, and like our video and subscribe to our channel to see more videos coming in the future. Thank you and see you soon.